Hi everyone, this is the video on solving right triangles. So just to kind of recap what we've done in right triangle world so far. In right triangles, we have a couple specific properties and a couple specific tools to work with them. We looked at the Pythagorean theorem, which says if we have a right triangle, you should take the two legs, the two perpendicular sides, square and add them, and you would get the square of the longest side, the hypotenuse. We also know that the hypotenuse is the side opposite the right angle. We looked at special right triangles, so we know that if we have a 30, 60, 90, this is about the angles, 30, 60, 90, or 45, 45, 90, that the ratio, the relationship, whatever you want to call it, of the sides follows a specific pattern. We looked at right triangle trigonometry and inverse trigonometry, and we said that was trigonometry at its base is a ratio or relationship between the measure of an angle and the length of its opposite adjacent sides and or the hypotenuse. Now we have to look at something else. What can we do with these tools? To solve a right triangle means to find all the unknown sides and angles. So in some of the videos that we've looked at on the other topics, we found one side, maybe two sides, maybe a missing angle. Now we're putting it all together. Find everything you are missing. We have several tools to do this. Pythagorean theorem, we should use that if ever we know two sides. We have special right triangles if we know 30, 60, 90, or 45, 45, 90. Otherwise, they're not going to help us. To be quite honest, I don't use them all that much at this point. And we have right triangle trigonometry and inverse trigonometry using those formulas. In order to solve a right triangle, we need to follow two rules. First rule, use what you are given as much as possible and use what you find as little as possible. Why do I say this? Using the given information as much as you can and not using what you find means that your work is less reliant on things you do, so it's resistant in a little bit, in a little way to you making a mistake. Second, don't use a complicated tool when you can use an easy one. If the Pythagorean theorem works, use it, okay? If you have a 30, 60, 90 and you've memorized those rules, then use that. If you have a good grasp of trigonometry and that's easiest for you to use, then just keep using that. Don't try to use a complex tool just for the sake of saying you did. Okay, that just adds time and effort to something that doesn't need that much time or that much effort. Okay, so let's take a look at some sample problems. So in this figure, we're asked to solve the right triangle. So the first thing I always do, if it's not done for me, I always label all of the angles. And I will almost always call the right angle C. That way, if I need to use the Pythagorean theorem, the opposite side, little c, would be the hypotenuse. So I could use the Pythagorean theorem as we're used to writing it. Again, sometimes you'll be given that option. Sometimes they'll label the triangle for you and you'll just have to work with what you're given. So you just got to see how the problem presents itself. Okay, so the next thing I do is I like to go ahead and even if there's values in place, I like to label the sides with the lowercase letter that goes with their angle, their opposite angle. So CB would be little a. Across from right angle, the hypotenuse would be little c. Across from angle B would be little b. And then I make a list. The measure of angle A equals the measure of angle B equals the measure of angle C equals little a equals little b equals little c equals. And this way I know that I have to fill in 6 things. I need to find 3 angle measures and 3 side lengths. And then now again, this is a system. This is what we call in math a systematic way of doing things. And what that means is, and this is why you should do it yourself, and not just in this, but in any math problem situation, is this helps you make sure that you complete the problem. This makes sure that you find what you're being asked to find. This makes sure that you don't leave something undone by forgetting a step. So I label the figure as much as I need to. After that, I make a list of the 3 angles and the 3 sides, so the things that I'm being asked to work with in this problem. And then from there, I will now fill in what I know. I know that the measure of angle C is 90 degrees. Why? Because that's the right angle. I know that the measure of angle A is 37 degrees, because that's given. I know that little a is 14, because that's also given. So I need to find one angle and 2 sides. Okay, finding the one angle is actually pretty easy. The measure of angle B would be equal to 180, because we know that all triangles add up to 180 degrees, minus the 37 degrees from angle A, minus the 90 degrees from angle C, and we would get 53 degrees by doing that subtraction. Okay, we have all 3 angles now. All right, I need to find B and C, the sides. Okay, now, here's where it gets interesting. Remember what I said. Use as much as you can, as much as you are able, what they give you, not stuff you found. So as much as possible, we're not going to use that 53. We're going to use 37. And we need to use trig because we know that 37 is not 30, 60, or 90. It's not 45. So because of that, our special right triangles don't apply. I only know one side in the right triangle. I cannot use Pythagorean theorem. And then trig is my only other option. I have to use the angle that I know. I have to use 37 degrees. According to 37 degrees, we'll find B first. B is adjacent. Why do I know it's adjacent? Because it connects to angle A, but is not the hypotenuse. So I have adjacent and opposite. Why do I know 14 is opposite? It's across from the letter A. Opposite and adjacent make the tangent. Tangent is opposite over adjacent. So we're going to say that the tangent of angle A is going to be equal to the opposite side over the adjacent side. And I'm actually, instead of putting the A there, I'll just put in the numbers. Tangent of 37 equals opposite 14 over adjacent lowercase b. All right, I solved this like algebra. Now, a couple things. First, I have to get b out of the denominator. I'm going to multiply both sides by b. B goes away on the right. I have b tangent 37 equals 14. Now you might be saying, what about tangent 37? I don't do anything with tangent 37 because it's a nasty decimal number that I don't want to deal with. The same is true of probably 99% of trig functions. So what I have to do, or I should say what I should do, I just leave it as tangent, sine, cosine of whatever angle until the very last step and put it into the calculator at the end. Just because it's easier to write tangent 37 than it is to write the long decimal version of whatever that is. So I need to get b by itself. Divide both sides by tangent of 37. Tangent 37. So I have b equals 14 over tangent 37. I'm going to need the calculator for that because that's definitely not, tangent of 37 is definitely not something I know. 14 divided by tangent 37. Before I hit enter, I'm just quickly going to hit the mode button. I see that degree is highlighted, so I know that I'm in the right mode here. And I get about 18.58. Rounding directions will usually say sides to the nearest hundredth. So that's good, 18.58. All right, I need to find side C now, the hypotenuse. Okay. Two ways to do it. I'll tell you both of them. If you want to break the first rule I gave you in favor of using the second rule I gave you, if you are very confident in what you did, you are certainly welcome to use the Pythagorean theorem here with the 14 and the 18.58. Or you can follow, that would be using a simple tool instead of a complex one, right? Or you could follow the first rule and continue using just the 14 and the 37 and go back and use a different trig function to find little c. That's what I'm going to do. So just for purposes of the video, I'm going to take this and make it smaller just so I can fit all of the trig work in the same part of the image. Okay, so I still have opposite 14. I know that little c is the hypotenuse, so I know that sine is opposite and hypotenuse. Okay, so I'm going to say that the sine of 37 equals opposite 14 over lowercase c. Same process as before. Multiply by c on both sides. I get c sine 37 equals 14. Divide both sides by sine of 37. I'm going to go over to the side. I would get little c equals 14 over sine of 37. And then I'm going to do that on the calculator. 14 divided by sine 37. I'm still in degree mode. I get 23.26. And there we go. I now have all three sides and all three angles. So that's how we solve a right triangle. Okay? Now, a couple things. If we have this, there's a couple different ways to give you information. I have to give you a right angle. There's no way around that. Okay? I have to give you at least one side. Okay? Because all of the tools that we know about right triangles rely on at least one side. Okay? So this is the nice version. This is what I call the nice version. I gave you one side, one angle, plus the right angle. So finding the sides was a little complicated, but finding the last angle was relatively easy because I just had to subtract from 180. I could also give you the rather nasty one, and I'm going to tell you right now that the right angle, I just didn't put it in, is right here. I could give you all three sides. Why do I say all three sides is the nasty one? Because you have to use inverse trig twice to really be exact about it. You can't use Pythagorean theorem because you know all three sides, and you can't use regular trig because you don't know any of the angles, so it wouldn't make sense. We wouldn't be able to complete it. So I'm just going to go right here. We're going to find this angle at the top. I'll call it A. Sine of A equals the opposite 5 over the hypotenuse 13. So A equals, remember we have to inverse because we want to find an angle when we know sides. So we would do sine inverse of 5 over 13, which is 22.6. We'll call that 23 degrees. If you want to be super exact to find the other one, we'll call it B. You're going to use the hypotenuse again, but you're going to use the opposite this time as 12. So the sine of B equals its opposite side, 12, still over hypotenuse 13. And we're going to do sine inverse again. And that's about 67 degrees. We could have also subtracted from 180. Maybe you don't think that's too complicated, but I think it's a little bit complicated. Thanks for watching.